next video in assignment problem is maximization case and multiple optimal solution. Here in the question itself they have been given maximize the following assignment problem, and first initially you have to convert the maximization problem to minimization problem by choosing the highest value of the whole matrix. By seeing this matrix, what is the highest value? That is 41. Now subtract each value of the matrix from the 41 value. So 41 minus 32, 9. 41 minus 38, 3. 41 minus 40, it's 1. 41 minus 28, it's 13. 41 minus 40, it is 1. 41 minus 40, 1. 41 minus 24, 17. 41 minus 28, 13. 41 minus 21, 20. 41 minus 36, 5. Like that you have been done for the next 3 rows also. You got this matrix. So from this matrix you are going to do the row reduction. That is your first step of Hungarian method. So in row reduction what you are going to choose? In the first row there is there are 2 least values. You can choose one as your value of row which you are going to deduct. So we are going to do the row reduction by the further reducer matrix. So what you got? 9 minus 1, 8. 3 minus 1, 2. 1 minus 1, 0. 13 minus 1, 12. 1 minus 1, 0. In the second row, the least value is 1. So you are going to reduce 1 minus 1, 0. 17 minus 1, 16. 13 minus 1, 12. 20 minus 1, 19. 5 minus 1, 4. In the third row, there is a 0. That's why that value of row you are going to write as it is. 0, 14, 8, 11 and 4. In the fourth row also, we have 0. So write as it is. That is 19, 3, 0, 5 and 5. In the fifth row, there is least value, that is 1. You are going to reduce the value of 1 from every value of that row. So 12 minus 1, 11. 8 minus 1, 7. 1 minus 1, 0. 6 minus 1, 5. 2 minus 1, 1. Hence, row reduction completed. Now, we are moving on to the column reduction. Whereas, in the column reduction, in the first column, there is 0. Write as it is. In the second column, the least value is 2. Now, you are going to reduce the value of 2 from every value of that column. So, 2 minus 2, 0. 16 minus 2, 14. 14 minus 2, 12. 3 minus 2, 1. 7 minus 2, 5. In the third column, there is 0. So, write as it is. Now, in the fourth column, the least value is 5. You are going to reduce that value of 5. So, 12 minus 5, 7. 19 minus 5, 14. 11 minus 5, 6. 5 minus 5, 0. And 5 minus 5, 0. And in the last column, there is 0. You are going to write as it is. Hence, by completion of row reduction and column reduction, we are moving on to the assigning zeros. The assigning zeros has been done for the column reduction matrix. So, in the first row, there are 3 zeros. Skip that row. In the second row, there is only one single zero which should be assigned. That's why assignment has been done here. Okay. And no zero will be there in that column. So, this zero has been cancelled. In the third row, there is 0 but it is cancelled. And in the fourth row, there are 2 zeros. Skip that row. And in the fifth row, there are 2 zeros. Skip that row. Now, we can move on to the column examination. In the first column, already one assignment is done. In the second column, there is only one single zero. So, assign that 0 and cancel these 2 zeros in the first row. When the assignment is done in the column, we have to cancel the zeros in that row. Now, we are going to have a optimal solution while taking the value of assignment randomly. That means you are going to get here multiple optimal solution. Why? Because in the fourth row there are 2 zeros and in the fifth row there are 2 zeros. Likewise, in the third column there are 2 zeros and in the fourth column there are 2 zeros. So, we are going to make a random allocation here. So, if you are going to give assignment here, this 0 will be cancelled. That's why I have been cancelled here. If you are going to give assignment here, this 0 will be cancelled. So, this is your first multiple optimal solution. Now, what is the second one? The second one is by giving the same matrix and the assignments are also same, that is 1, 2. But in the second matrix, what you are going to choose? This matrix this 0 you are going to choose as your allocation. So this 0 will be cancelled and this 0 you are going to give assignment and this 0 will be cancelled. So this is your assigning zeros. After giving assigning zeros, we have to check that either you got 5 number of assignments or not. Why? As you are having 5 rows and 5 columns, we are having only 4 assignments. That's why we are moving on to chain of marking. The row that which is not having any assignment, tick that row. In that ticked row, where 0 is there, tick that column. In that ticked column, where assignment is there, tick that row. Now, cut the unmarked rows and marked column. Now, we are moving on to the next step, that is what is the least value of your uncovered elements? The least value is 4 from the uncovered elements. This value of 4 you are going to reduce from the uncovered elements and you are going to add the same value at intersection of the lines. Where is the intersection? Here it is 1, here it is 1 and here it is 1. You are going to add the least value of 4 at the intersection values. You got the reduced matrix like this. See, 8 plus 4, 12. This is covered by line. So, you are going to write as it is 0, 0, 7 and 0. And in the second row, it is not covered by lines. That's why we are going to write 0, 14 minus 4, 10, 12 minus 4, 8, 14 minus 4, 10, 4 minus 4, 0. And the third row, here it is 0, that is covered by line. As it is, you have to write 12 minus 4, 8, 8 minus 4, 4, 6 minus 4, 2, 4 minus 4, 0. Now, in the fourth row, these values are covered by lines. But this is an intersection value. So, what you are going to write? 19 plus 4, which is of 23. So, 1 is as it is, you are going to write 0, 0 and 5. This is also covered by line, but this is an intersection value where you are having 11. So, 11 plus least value 4 you are going to take, that is 15. 5, 0, 0, 1 you are going to write as it is. So, you got that the reducer matrix like this. The same copy of reducer matrix you are going to write at the right side also. Then you are going to give the assigning zeros. How you are going to give assigning zeros? See, in the first row there are 3 zeros, leave that row. In the second row there are 3 zeros, leave that row. In the third row there are 2 zeros, leave that row. In the fourth row there are 2 zeros, leave that row. In the fifth row there are 2 zeros, leave that row. Now we are moving on to the column examination. So in the first column there are 2 zeros, skip that column. In the second column there is only one single zero which should be assigned and no zeros will be there in that row. These 2 zeros have been cancelled. Okay. Now we can move on to the third column. In the third column there are 2 zeros. and in the fourth column also there are 2 zeros, and in the fifth column there are 2 zeros. So we can take the random allocation again. So if you are going to give random allocation 1 0 here as assignment, then that 0 will be cancelled in that row. Okay, and no zeros will be there in that column itself. So this 0 will be cancelled. This is going to be assigned, and here also again you got an random allocation. That's why you can take here as a assignment, then this 0 will be cancelled. Here you are going to take assignment, this 0 will be cancelled. Now how many assignments you got? 5 assignments you got. You are going to write that this is a multiple optimal solution. You are going to write the value of z separately, and here after giving 1, 2, 3, these 3 values, here you have given allocation. In the next step you are going to give allocation here. This 0 will be cancelled. So if this 0 will be cancelled, this is the 0 which is assigned. No 0 will be there in that row. So this 0 will be cancelled. So here in the first matrix you have given assignment to the fourth row, fourth column. So here it is going to give fourth row, third column is going to be assigned, and this 0 will be cancelled. This 0 will be assigned, and this 0 will be cancelled. So we got the multiple optimal solution, and you got the value of z here as 191 and here also as 191. By choosing the values from the given question, you are going to write that solution. Thank you.